Hey everyone. In this Technology Insights edition of ITS Now, we're looking at how a normal traffic signal engineer has come up with a solution to an unintended consequence of technology advancements when they have to face a cold Colorado winter. Anyway, I'm Alastair and this is at ITS Now. Here's a question that sounds almost impossible. How can a perfectly functioning traffic signal, which is powered, is communicating, and is displaying the right indication, still failing drivers? The answer is simple and a little ironic. We made traffic signals dramatically more efficient by switching to LEDs. And in doing so, we removed something we didn't even realize we were relying on: waste heat. For decades, incandescent and halogen signal lamps were famously inefficient. A lot of the energy you paid for didn't become light, it became heat. In winter, that inefficiency had a side benefit. The lenses and housing warmed up. Light snow would melt. Slush wouldn't readily bond. Snow build-up was often self-limiting. Then LEDs arrived. Lower energy consumption, far fewer lamp changes, fewer call-outs. Everything asset owners wanted. But the lens surface is now much colder, especially in prolonged sub-zero weather, and that's where the new failure mode appears. When wet snow sticks and compacts on a cold lens, the signal can become snow-plucked, electrically correct, and physically unreadable. At best, this drives public complaints, emergency dispatches, and repeat site visits. At worst, it creates hesitation, hard braking, red light violations, and driver confusion, precisely when road friction is already reduced. So agencies look for fixes: heated heads, add-on heaters, extra inspections. Those can work, but they add wiring, controls, power draw, and ongoing maintenance. In other words, we start doing away with the efficiency we gained with LEDs in the first place. Or they just need to use other more extreme measures. Snowproof Signals takes a different approach. The elegantly pragmatic solution: change the geometry, not the electrics. Don't try to melt the snow, stop it accumulating in the first place. Their snow cone is a clear, cone-shaped cover that fits over the signal lens. No wires, no thermostats, no power. It's passive, so it can't fail to turn on. And the engineering idea is beautifully practical. If snow is sticking to a flattish face, don't fight physics with heat. Change the shape so physics works for you. As air moves through and around the hood, the cone guides the flow so snow and spindrift are less likely to bridge across the lens. Faster moving air is encouraged to sweep down the cone and out through a gap at the hood edge, helping carry snow away rather than letting it settle. And because the surface is tapered, gravity does the rest. Snow and slush have less flat area to pack onto and more incentive to slide off. In plain terms, the worse the wind and blowing snow, the better it works.
Remember to hit the subscribe button for ITS Now.
Engineers love solutions that reduce failure modes. Heating systems introduce components: power supplies, wiring, sensors, controls, each with its own installation and maintenance burden. A passive retrofit does the opposite. It removes dependency. The snow cone works whenever conditions demand it. From Snowproof Signal's own product information, the pitch is deliberately simple. And that's the point. 0 electrical components, quick installation, often described as just minutes per head, and a long service life, measured in years rather than seasons. This is elegant because it's not trying to outsmart winter with more technology. It's correcting a technology side effect with first principles: aerodynamics, geometry, and gravity. And it looks really cool too. And it's pragmatic because it's deployable where it matters most. Exposed rural approaches, bridge decks, high-speed junctions, windward faces, without committing your entire network to higher power consumption. Of course, any change to the signal face needs sober checks. First, the optical performance. Does the cover introduce reflections, glare, or reduce contrast in low sun or rain at night, or with headlamp backscatter? Second, maintainability. If road film accumulates on the outer surface, how does cleaning change, and how often? Third, compatibility and standardization. Does it fit the existing housings, visors and backboards you already operate? And does it preserve the recognised appearance and viewing performance required by your local highway standards and approvals process? These are normal engineering questions, and the fact that we can ask them about a simple physical add-on rather than a powered subsystem is part of what makes the approach attractive. The broad lesson is one we see again and again in transport. When you optimize for one parameter, like energy efficiency, you sometimes remove a hidden benefit. LEDs gave us lower power and longer life, but they took away the free heat that kept lenses clear in snowfall. Modern traffic signals can draw as little as 1 watt compared to 50 or 60 watts for a comparable light output with an old-fashioned lamps. Snowproof Signal's cone cover is an elegantly pragmatic fix. It restores visibility without eroding the efficiency gains that prompted the LED transition. It's a reminder that some of the best engineering isn't flashy. It's the quiet, reliable kind that keeps the system operating safely when conditions are at their worst. As you'll probably gather, I really like this product. I think it offers a pragmatic but still elegant solution, which is actually more sophisticated than it looks. As technology engineers, we are often guilty of over-engineering solutions, so I think this should act as a reminder to people to not overcomplicate things. Anyway, what are your thoughts on this? Let us know in the comments below. I just wanted to thank Chris Bichon at Snowproof Signals for taking part. There will be some links below to find out more about them, and also don't miss reading about this along with lots of other items in ITS Edge magazine, and have a look at the ITS Now website too. Lastly, if you haven't done so already, please could I ask you to click subscribe to our channel. It really does help us to bring you further videos about ITS. Thank you again to everyone who has already subscribed. And no, it doesn't cost you anything. Thanks for watching. See you next time.